Expanding quadratic expressions and word problems. Our learning goals for today are to convert from factored form to standard form of a quadratic expression and answer word problems involving the factored form of a quadratic expression. Please ensure you have the lesson printout so you can follow along with this video. The standard form of a quadratic equation is in the form ax squared plus bx plus c. We can turn the factored form of the quadratic to the standard form by expanding the factors. One thing to point out is in the standard form, the c value is the y-intercept. This makes sense because when x is equal to 0, the a and b terms will just all equal 0, and what is left is just the c as the y-intercept. Let's begin with some examples, expanding the factored form. Recall, when expanding the factored form, we use the method known as FOIL. FOIL stands for first, outer, inner, and last. For example, we multiply the first in each bracket, so a times a, we get a squared. Then we do the outer, a times b, so we get one of the ab here, and then we will do inner, b times a, and then last, b times b, we get b squared. And then we simplify by adding the two middle terms, because they have like terms, and we get our simplified expression. So let's use that technique here. Let's try expanding these expressions. Let's do first 3x times 2x. This will be 6x squared. Outer, 3x times negative 1, negative 3x. Negative 1 times 2x will be negative 2x. And then negative 1 times negative 1, positive 1. Then we collect like terms in the middle, and we simplify our expression. Let's try B. 2x times x, 2x squared. 2x times 1 plus 2x. Negative 5 times x, negative 5x. And negative 5 times 1, negative 5. We add our like terms in the middle. 2x squared minus 3x minus 5. And our expansion is complete. Try pausing the video here and doing the following examples on your own and see if you get the same answers. Pause the video now. Okay, so let's try example D here. So we have 8x times 6x. That's going to be 48x squared. Then we have 8x times negative 7, which is going to be negative 56x. Then we have negative 3 times 6x, which is going to be negative 18x. And then negative 3 times negative 7, which is going to be positive 21. Just one thing to note, just be mindful with the signs. You remember a positive and a positive is positive, and a positive and a negative is a negative, and a negative and a negative, when you're multiplying them, is a negative. So now we're just going to group like terms together. So we have 48x squared, negative 56 plus negative 18 is equal to negative 74x, and then we have plus 21. Okay, and let's do this next one over here. We have 4x times 7x. It's going to be 28x squared. 4x times 6, which is plus 24x. Negative 3 times 7x, that's negative 21x. And negative 3 times positive 6, that's negative 18. And now we're going to add these two like terms together. So we'll have 28x squared. We'll have 3x plus 3x. and negative 18 over here. So in this section here, we're going to determine the equation of the parabola in factored form, then express our answer in standard form. To do that, we're going to use the skeleton right over here of the factored form. Y is equal to a bracket x minus s close bracket x minus t close bracket. Now, just so you recall, s and t are the x-intercepts. This is one x-intercept, and this is the other x-intercept. So we just have to plug those values in there, and then we'll be able to start solving it. So let's take a look at step 1. First, determine the zeros or the x-intercepts. So we can see one of them right over here, and that occurs at negative 4, 0, and then one right over here, which is 2, 0. So we know our s and t essentially. S is negative 4 and t could be 2. Doesn't really matter the order, you just have to happen there. So let's plug those into our equation here. So we have y is equal to a bracket x minus s bracket x minus t, and we're going to plug those values in for our intercepts negative 4 and 2. And so we'll say y is equal to a bracket x minus s, which we said was, we'll say is negative 4, and then t we said was 2. Okay, and you can see when I put that s in there as negative 4, we have that double negative sign, so we're just going to simplify that, and I'll do that right over here. Y is equal to a bracket x plus 4. The two negatives make a plus, and then this one is just going to be x minus 2. Okay, so continuing on, I'm just going to rewrite the equation as we know it so far. So x plus 4, x minus 2. We don't know what the a value is yet, but we're going to figure out what that is. And so step 2 says, analyze the parabola for any points that you know. Okay, we're just looking for a point that we can clearly see the x and y value. Okay, so we're looking here, if you look at your parabola, and we can see a pretty good point right over here. And this happens to be our y-intercept, and the coordinates for this one is 0, 4. So let's write that in. And so we know when x is equal to 0, y is equal to 4. So 0, 4. You don't have to write this down. You can go straight into step 3, which is we can solve for a by plugging in the zeros and the known point. So into our equation, our skeleton equation, we're going to plug in all that we know. So we know y is equal to 4 when x is equal to 0. So let's plug that in. So y is equal to 4 when x is equal to 0. And then let's figure out what a is. So we're going to simplify what's in the brackets. So 0 plus 4, that's 4. 0 minus 2, that's negative 2. We have an a, and then we have our 4 up front. Then we can multiply on this side the 4 and the negative 2. So I'm just going to bring that up here. So 4 is equal to a bracket. 4 times negative 2 is negative 8. So we have 4 is equal to a times negative 8, and then we're just going to divide both sides by negative 8 to get rid of it on this side, so we get a by itself. So a in this case is going to be equal to 4 divided by negative 8. If we reduce that, that becomes 1/2. So now we could rewrite our equation in step 4 in factored form. So we know a is equal to 1/2, so let's write out everything that we know so far. So we know y is equal to negative 1/2 in the brackets from here, x plus 4, x minus 2. Right. So in step 4, we wrote our equation in factored form. In step 5, what we're going to do is we're going to expand our equation to get it in standard form. Now, when I expand my factored form, I always like to work with the binomials first. So let's do that. We have y is equal to negative 1/2 And I'll just rewrite the whole thing here again one more time. So let's expand the binomial first. So let's FOIL. First we have x times x. So leave the 1/2 in front, or the negative 1/2 in front. So you have x times x, which is going to be x squared. And then we have x times negative 2, which is going to be negative 2x. And then 4 times x, which is positive 4x. And then 4 times negative 2, which is negative 8. And then we can add like terms together, and I'll bring that up here. So you have y is equal to negative 1/2. And then inside this bracket here, we have x squared, and then negative 2 plus 4, that's going to be plus 2x minus 8. And now what we can do is multiply this negative 1/2 into each of these terms. So when we do that, we're going to get negative 1/2 times 1x squared, so it's going to be negative 1x squared. We have negative 1/2 times 2, which is actually going to become negative 1x, and then negative 1/2 times negative 8, which is going to become plus 4. And so here we have our fully expanded form of the quadratic equation. And notice here we can see the c value is 4, and as we said earlier, the c value in standard form is actually the y-intercept. And if we look up here, we can see our y-intercept is actually 0, 4. So this is our final answer here. That's what it looks like. So example 2 is just like example 1. We're just going to go through and break down all the steps. So the first thing that we're going to do is find our x-intercepts, which is right over here and here. So we have our x-intercepts at negative 5, 0. And then over here we have negative 1, 0. Okay, and so we can either write those out, or we can skip straight to putting them into our skeleton equation. So we have y is equal to a bracket x minus s bracket x minus t, and what we can say is s is equal to our negative 5, and t is equal to negative 1. So let's fill this bracket in here. So we have y is equal to a x minus 5 x minus 1, and then we know when we have those double minus signs we can clean that up, simplify that. So x plus 5 and then x plus 1. And now we need to figure out what a is, so we need to find a good point on our graph. So analyzing our graph, we can see a pretty good point right over here. Again, it happens to be our y-intercept. It's not always going to be the y-intercept, but this one is clearly this one here. So we know when x is equal to 0, y is equal to 5. Okay, so we're going to plug that information into our graph, or sorry, our equation so far. So we know y is equal to 5 when x is equal to 0. And so we're just going to simplify the bracket. So we have 5 is equal to a, 0 plus 5 is just 5, and 0 plus 1 is just 1. So we're going to get something that looks like this. And then we're going to multiply what we can on the right-hand side here. So 5 is equal to a times 5. So 5 times 1 is 5. And then we want to get a by itself, so we're going to divide out 5 on both sides. So 5 divided by 5 is 1. So a is equal to 1. And now we can rewrite our equation with everything that we know. Y is equal to 1 times x plus 5 bracket x plus 1. And now we simply expand to get it in standard form. So we have y is equal to, let's do the brackets first. Well, that 1 is just going to keep everything the same, so it doesn't really matter. So we have x times x, which is x squared, x times 1, which is going to be 1x, 5 times x, which is 5x, and then 5 times 1, which is 5. Now we're just going to add these terms together, the like terms in the middle here. So y is equal to 1 bracket x squared plus 6x plus 5. And then when we simplify this, y is equal to x, we can get rid of the bracket, x squared plus 6x plus 5, and that's our completely expanded form there. So we have example 3 over here. Why don't you try this one on your own? You can pause the video here, and you can resume the video afterwards to see if you get the correct answer. So you could pause the video now. So the first thing that we're going to do is find our zeros, and we can see them here. This is 4, 0, and this one here is 0, 0. So those are our 2 zeros. So we can already fill this in for our s and t. We can say s is equal to 0, t is equal to 4, and we can start plugging it into our skeleton equation here. So y is equal to a, bracket x minus s, bracket x minus t, and then we're just going to plug in our s and t values into that. So y is equal to a, so x minus 0, and then x minus 4, and we can actually simplify this as x minus 0 is just going to be x. So y is equal to a, x, and x minus 4. Okay, so the next thing we need to do is find a good point. And one thing to note, if your x-intercept and your x value is the same for your x-intercept, we can't use them, it won't work. So we have to use something that's different. And so we do have a better point that's up here, which is the vertex. So we're going to use this point, the vertex, which is at 2, 4. So we're going to plug in this information into our skeleton equation. So when x is equal to 2, y is equal to 4. So let's plug that into our equation. So 4 is equal to a times x, which is 2, bracket 2 minus 4. And now we can solve for a. So let's bring this up here. So we have 2 minus 4. So I'm just going to rewrite this bracket and simplify it here. So 2 minus 4 is negative 2. And we can solve for a now. So we have 4 is equal to a. 2 times negative 2 is going to be negative 4. Now we want to get negative 4. We want to get a by itself, so we're going to divide out negative 4 on both sides. So this is going to cancel. So 4 divided by negative 4, that's equal to negative 1. And we have a left over here. So we know a is equal to negative 1. Now rewriting our equation, we would have this in standard form. Y is equal to negative 1 a, negative 1 bracket x bracket x minus 4. And now we can expand that. So this one here, you can see this is just a monomial, so this is going to be a little bit simpler to expand. We'll leave the negative 1 here, but we'll do the monomial into here. So we have x times x, which is x squared, and then x times negative 4, which is negative 4x. And we saw that it's negative 1 in front, so we're going to rainbow this into both of these here. So y is equal to negative 1x squared plus 4x. So just be careful with that rainbowing in, and you should get your answer right over there. Let's try some word problems associated with the factored form of quadratic expression. Ryan owns a small music store. He currently charges $10 for a CD. At this price, he sells about 80 CDs a week. Experience has taught him that a $1 increase in the price of a CD means a drop of about 5 CDs per week in sales. At what price should Ryan sell his CDs to maximize his revenue? So at Ryan's current revenue structure, it looks like this. We know revenue is the amount he makes, which is equal to the price per CD times the number of CDs sold. Currently, his revenue is equal to $10 per CD times around 80 CDs a week, it says. As you can imagine, there is some increase we can make to the price that will give us a maximum number of revenue, maximum amount of revenue. So we're going to let Y equal our revenue, and we're going to let X equal our number of increases. And so Ryan states that for every dollar he increases, so one increase means we're increasing by $1, equals the loss of 5 CDs per sale. So for every one increase in price we have here, one increase in dollar, we're losing 5 CDs. So we get 5 increases of losses. And this would equal our total revenue. Now, if we were to graph this, we'll get some sort of parabola that looks like this, where the zeros on our parabola are when we make 0 revenue. And we can find a maximum between these 2 points. That'll be the maximum revenue that we can make. So to do that, we need to find our zeros and then find our midpoint and then find our vertex. So let's go ahead and do that. So we want to find out first our zeros. What would make our revenue 0? So we're going to set Y to 0, and we'll get something like this. Now we have to find our X values that would make both of these factor brackets true. So 10 plus X is equal to 0, and we have 80 minus 5X is equal to 0. And so we're just going to solve for what X would be in both of these cases. So this one's easy, we just move to the other side. X is equal to negative 10. And this one, we're going to move the 80 over to the other side. So we have negative 5X is equal to negative 80. And then let's just solve for that. We're going to divide this side by negative 5 and this side by negative 5. And we're going to get an X value here of 16. So this would make our equation 0. So if he reduced his price by $10, or 10 increases, this will go to 0, and then he would get, he's charging $0 for a CD, which would means he makes $0. Or if he loses up to 16 sales, or 16 increases would make this part of the equation 0 as well. So that would be the 2 cases where we get our X value. So now we have to find the midpoint between there to find our maximum. So to do that, we just do our X mid is equal to negative 10 plus 16, or X's, divided by 2. And we're going to do that. So we get 6 divided by 2 equals to X mid. And so X mid is equal to 3. So to get our maximum value, he would need to have 3 increases. Okay. In this question, it just asks what price should he sell his CD at, which means 3 increases, which means we can plug that into this equation here, or it's into this bracket. So we know it's $10 per CD plus 3 increases of $1. So he'll be selling his CD for $13. We can also find the number of CDs that he's going to sell for that amount if you plug it into this section of the equation. So he's selling it for $13, and we have 80 minus 5 times 3. 5 times 3 is 15, so we have 80 minus 15, which is 65. So he'd sell it $13, and he'd sell 65 a week, and if we multiply those two, we can get his total revenue. So his total revenue, if you were to sell it at this price, would be $845, which is more than his current revenue. So if he sells CDs for $13 and expects around $65 CDs sold, he'll make around $845 in revenue. And just to make sure we're answering the correct part of the question, at what price should Ryan sell his CDs to maximize his revenue? He should sell his CDs for $13. So let's just finish with the concluding statement. Ryan should sell his CDs for $13. And so you're going to see a variety of questions like this that are going to be maximum or minimum questions, but it'll all be something like this where we see an increase in one and a decrease in another, or some variation of that.